All right, so let's hope that we can confirm our predictions here by actually doing it, and Professor Drennan will help me out by loading up our device with electrons, and I'll explain exactly what our setup here is as she does that. So basically what we have is this zinc plate here. So that's what we want to load up with electrons and then see if we can remove some. But that's a little bit hard. We aren't all that good at seeing the electrons with our eyes, so we need to think of a way to do this. So what she's going to do is start loading up the electrons, and you see this wand here will slowly, and it takes a while to do it, start to become perpendicular. The reason for that is because all of this is connected, so we're moving electrons everywhere in the system. And since we have two bars that are together like this, once they're both loaded up with electrons, there's going to be negative charges that repel. So the electrons will want to get as far away as possible, and they're on their slow way to doing that, to getting as far away from each other as possible. And if we do, in fact, hit it with light to get the electrons off, it will go back to the straight up in position, or if it gets knocked hard enough, it does that too. Sometimes it's easier actually not to touch it to the metal. I should have.
It's hard to see if there's something behind it.
Oh, I see. Yeah.
It's hard to see if it's moving or not.
So our technology TA is also our paper TA. Darcy will hold up the yellow paper. All right, there we go. Now we're making a little progress. Oh, that got.
It was moving before, you just couldn't see.
Okay. So does anyone have any questions about the setup here? Does it make sense? We're looking for the bar to go back once we make some progress. This demo works wonderfully in the winter months in Boston when we will all be full of static at all times. We're still close enough to the summer that the air is not just filling us up with extra static electricity, so it's a little more challenging here. We'll try to make this happen only once. I think that's probably, if we can get one more. So it works. I think it's just getting too much momentum back. Sometimes it helps to not actually hit the metal, just put it next to the... There we go. I wonder if there's some UV light coming out of this new lighting setup in our classroom here. That would be a little tricky. Actually, is this turned off too? All right, I think if this sticks, yeah, it's the pressure of the paper. I think that's good enough. We'll be able to see. If you can keep showing that, though, Darcy, we'll try different scenarios, and I'll try not to put laser in your eye. So, actually, you can look down as well as an added precaution. All right, let's try it with that. That's enough then. So the first thing we're going to try is with the red laser pointer, because that we are expecting not to have an effect, and that will prevent Professor Drennan from having to charge up our apparatus again. So Darcy will look down at this moment, and we will hit this with the laser pointer, and what we see is nothing is happening at all. Okay, good. Control 1 working. So now we'll very carefully take our UV light source. Darcy, again, will divert her eyes and her skin. Let me make sure this is actually on. Actually, I don't think it is. Yeah. Oh, okay, we've got UV light here. And let's see what we can see. And we lose electrons if that's what's happening. And it often doesn't go all the way because actually this device gets stuck right there. So let's charge it up again and see if we can check again. But did you see movement? Are you buying our story here? This is actually very representative of when you do research in the laboratory. You will find often things do not work quite exactly as they worked 20 minutes ago when you just checked it in your office, for example. And sometimes it's a matter of factors that you need to figure out what it is, and maybe it's that there's extra light in the room we don't know about. It might just be... Yeah, so now we did get it back to the starting position. Next time maybe we'll charge it up before glass. All right, so we kind of saw what was happening here. You saw it move a little bit. They'll keep trying to get it going, but maybe we should move on with our lives here while this is happening. And we'll click it back at the end, and if we have a nice setup at any point, I'll just stop and we'll go back and we'll look at it again. Since I think that's just not going to happen right now. So let's switch actually back to our notes. So ideally what we did see was, in fact, it does have enough energy with the UV lamp. It wasn't a dramatic shift you saw because we didn't start very high and then it went to that stuck point. But luckily we had the control of the red laser pointer where nothing moved at all. So hopefully you're convinced that your predictions worked well and you are able to predict what's going on when you're looking at the photoelectric effect. Let's try this one more time. Just so you can see it. It'll still likely get stuck in that spot, but we'll just show you one more time the effect of the UV light. And actually, we'll throw in an extra trick here, too. We know that UV light gets absorbed by glass, so it shouldn't be able to go through the glass. So first, if Professor Drennan can try it through the glass, and we see nothing's happening, let's move the glass away. All right. All right, good. So we can fully believe what our calculations were now, which is a nice thing to do. Let's